Alright, hello again. This time we're going to make a drag knife. Yeah, a drag knife. A drag knife. Right then, here's the scenario. Down at work I need to cut cardboard to make boxes, specific boxes. Yeah, I can't get boxes for some of the products we make that fit properly, so we're thinking of making our own. Also, some of the products I actually sell have a cardboard inner, which is part of the product. So I'm fed up with guillotining bits of cardboard up. So I'm going to make a drag knife, and this is the blade we're going to use. So here it is. This is what it will look like, hopefully. I've had a little look at what this isn't a new type of design. There are commercial versions of this out there. However, I've been looking at them and I thought, why would you do that in this modern day and age? And most of them, the blade here is completely exposed at the front. Why would you do that if in this modern health and safety age if you didn't need to? So I've actually encased it so that it's less likely that when you're taking the thing off the mill or router, I should say, or putting it on, that you're not going to slice lumps out of your hand. Take it from me. So I've encased it. Let's go back to the main view and I'll show you exactly what's in here. If I turn the axle off, there you go. And in fact we'll turn the bearings off and the clamp that holds the blade in. Right, so it's just a simple bit of flat turning, milling, that's the word I'm looking for. Simple bit of milling with a spindle on the top. On top of that we fit a bearing. There'll be a spacer that I haven't modelled and another bearing, and then over the whole thing goes an axle. So the blade carrier here will be able to spin irrespective of whether the spindle is moving. So and the last thing you should do with these is turn the spindle on, because you'll turn this into a missile. So let me just turn those bits off. Actually, let's turn the blade clamp off as well. And in fact the blade, there you go, that's the bit we've got to make to start with, which is actually quite a difficult piece to do. Off camera I've whopped out a bit of alley to roughly the right shape. I need to put this in the lathe and turn this piece down so that it's a diameter 12. This part, I've been thinking about this, is actually quite a difficult part to hold, because the finished shape, there's nothing that's square or parallel for you to get a good grip on the vise. So and I did think that once this is round I could hold it in my fourth axis, machine one side and just spin it over and machine the other side. The problem with that is that the chuck, the problem with holding it in the fourth axis is the chuck is so big that I won't be able to get close enough access with the tool. So I'm quite limited in tool space. I'll just get that and show you. This is the tool I'm going to use for most of the operations. It's because it happens to be in the tool holder. I might change it for a new aluminium one, but this is a 4-flute, 4mm. So there's, with the chuck holding this part, I'm going to crash the tool into the chuck. So I've come up with another solution which I think should work for another project, another work project that I'm not going to show you. I made this, which is a pallet. This sits in my vise, and I've marked it so that it always goes in the same way. And I'm going to use the painter tape thing. So we're going to actually super glue this part to this plate that's in the standard milling machine vise. So then I've got unfettered access. Yeah, but so you can see it easily. So I've then got unfettered access to everywhere I need to go, everywhere the tool needs to go on top of that part. And the flip side is really just a case of putting it in there and facing it off. So I'm not even going to make the code for that. I can do that easily within Mark III. So first op, put this in the 4-jaw in the lathe and make that cylindrical, because I can't, once I've machined everything else, I can't hold this part, so I have to do that part first. Here we are in the 4-jaw, and there's a little bit of wibble wobble, but we're not overly worried about that, because this part is about nearly 1 millimetre bigger than it needs to be. So with 1/2 mil off either side, as long as I'm within 1/2 mil of the centre, I'm golden. Okay, there we have it. The only thing I've changed from the CAD drawing is I've tapped it with an M4, and because I just get the feeling I might want to add a screw to retain it inside its housing so that it can't fall out. That could be catastrophic. So here's the bearing, which is a light fit. There you go. Push fit. Here's the front. I was a bit sceptical about this as a sensible method to hold something while you're CNCing, because I thought the loads might be too high to make it work sensibly. But I have to say, having tried it on another part last weekend, I think it was, I was blown away. It took a real effort to actually get the bloody part off the finished off the pallet when I'd finished. I could just stick this on like so and use my finger to line the edge up, but I thought, as I have a surface plate, a knackered old scratched one, the best option is to do this, to line it up like so, clamp it up, leave it for 10 minutes for the super glue to get a decent bond, and then I'm away, and I know that I will be square to the mill. Woohoo! I would use my finger. Hell, no, I will use my finger. There we go. There we are. Give that a few minutes. While that's curing, setting, whatever the word is for super glue, cheap super glue, industrial grade super glue, yeah, I bet, I'll go and set the mill up, so that way. Here we are over at Sally the Sile. Let's just put this pallet in. We have a 4mm carbide tool in the spindle. I've set up the G54 0. Hopefully we shouldn't be too far out. Any deviation will bugger this up, this shaft here. So I've done a dry run at 20mm above. It seems to start correctly. So here we go. Cycle start. Head goes up to reference 0, then it should come down, go to 1mm above, there you go, and start plunging in. I'm not using coolant because I think it'll end up breaking the joint. And and the part will fly off. So oh dear, that's the end of that. Here's the problem. Chip weld. So I put a 2-flute in, which is specifically intended for aluminium. I'm also going to risk it by running a very light amount of coolant on. There we go. Op 1's finished, and I've jury rigged myself a mist system. There's a slow bleed of air coming out of here from Edward the compressor, and when the tool comes down, the nozzle just drips on the top of the blowgun, and it mists. So yeah, it's not elegant, but it does the job. This is interesting. It's a week later since I've did the last machining op on this part. I had to go to work, and I couldn't be bothered last week. So the next op is to go round the contour and nibble off effectively a bit along the bottom here, and hopefully tidy up the edges. But the thing that I think is interesting is this has been stuck, and for over a week now, and the painter's tape, it's slippery because there's clearly oil in the mist lubricant that I used last week, but it's absolutely stuck firm. So I do wonder, I'll have to do some experiments at some point, but I do wonder whether you could use flood coolant on this for a short job, a couple of hours or so, and still have it stuck on. So anyway, the next stop, like I said, is to do the contour. So let me get on with that. Right, I've finished the contour path. Got a reasonable finish on it. I'm quite pleased with that. Slight balls up here, but I caught it before it completely gnarled the part up. I changed the tool because I wasn't like the finish I was getting with a 4mm, so I put a 6mm cutter in, and I forgot to change the tangential extension, so consequently I nibbled a bit out of there. Anyway, it's not the end of the world. This is the final pass with a 2.5mm high-speed seal cutter, because I don't have a carbide one, so it's going to run quite slowly. So let's give it a bash. All that remains is to get this off. I've sharpened up a screwdriver rather than bugger up a decent chisel. And I'll try and get this up without damaging it. Too much. There we go, it's coming. Right, let's clean that up and go and have a look at it. Okay, so here we are. That's looking all right. I've yet to clear the back up. Like a numpty, I should have actually machined the back first, then flipped it and then machined the front. But here's a blade. Yeah, that fits more or less that way. There's a tiny little bit I need to remove at the top here. The blade is slightly different shape, I think. Right, so there we have it, assembled. I did face off the back in the end. I thought, yeah, looked a bit crappy, so I've made it look less crappy. Pleased with that so far. That looks almost good enough to work. Right, off camera I've started to turn up the bearing housing. So that's in there ready. The bearings... Oops, the bearings are a reasonable fit in the end there. You'll have to take my word for it. So all that remains is for me to cut this off to the right length and turn it down to fit in a collet. So and then we can press fit the whole thing together. 10 minutes later, actually more like half an hour later, I've turned up the axle, as I'm calling it. It goes in there like that with the two bearings. I also found I got some old piece of brass, bronze, whatever, kicking around, so I've made a little spacer to keep the bearings apart. So I've heated the bearings up and got them fitted, so with the little spacer. So they should be a push fit in here. They should be tighter fit than this, but I might just put a bit of Loctite in to make sure they don't fall out. So let's put the blade in. Ow, carefully. Whoops. Well, there we have it. My version. Here it is. I'm going to grab off that. My version of a drag knife. The only thing to do is to put it in the machine and give it a go. See whether or not it works. You can see that the actual drag knife is completely separate from the spindle. Right, here we go in real time. Right, so here we are. I think that came out pretty well, to be perfectly honest. Does the job. I only needed to cut out basic rectangles for a product we sell, and there are a couple of things I would change if I made it again. I'd move the bottom edge up somewhat so that more of the blade sticks out, and also I'd bring this edge here out more so that it stops the blade from moving. I've so far, with a couple of attempts I've had, the blade moves slightly, so they're the changes I'd make. Apart from that, I'm pleased with that. Thanks for watching, and please subscribe and hit the old bell button, and we'll see you again on the next one I make. Take care. Ta-da.